Hello and welcome to Easy Math channel. This is our part 3 of the exponent series where we will talk more about exponents but primarily focusing on negative exponents. In part 1 we discussed about multiplying and dividing exponents. We also talked about what exponents means and what base means. In part 2 we talked about dealing with exponents when they are separated with parentheses. And in part 3, we will specifically focus on negative exponents. And if you remember, in part 1 and part 2, we always talked about positive exponents. We never discussed about negative exponents and what to do with negative exponents. In this video, we'll focus on that. So I would recommend you go back and watch my video 1 and video 2 on exponents. And with that, let's dive into this part 3 of this video. So before we discuss about negative exponents, I again wanted to give a quick refresher on what exponents mean. So whenever we see a number which is 10 to the power 3 or 2 to the power 4, so anything which is in the power is called an exponent. And by the way, exponent is also known as power. And the number is the base. So 10 is our base and 3 is our exponent or power. In this case, 4 is the exponent and 2 is the base. And 4 is power or exponent. So what that means is whenever we have 2 to the power 4, we'll multiply through 2 4 times to get 16. And if we have 10 to the power 3, we'll multiply 10 3 times and we get 1000. Cool. So with that knowledge, let's talk about a couple examples of negative exponent, and let's see how to multiply when we have a negative exponent. So before dealing with multiplication, let's see what does it mean when we say 5 to the power of negative 3. So if you remember from the example when we have a to the power m, or a is the base, m is the power, and we multiply that with, say, a to the power, let me clean that up, a to the power n, we just say same base, and in terms of multiplying we just add up the exponents, so this would be nothing but a to the power m plus n. So in this case, let's substitute a with something, with say 3 and m say 2 and n with say -1, we'll use the same property. We will add the exponents, so 3, 2 plus -1, so this would be nothing but 2 minus 1, which is nothing but 3 to the power of 1, which is 3. Awesome. So in this case, negative 3 is nothing but 5 to the power of -3, which we can also write as 1 upon 5 to the power of 3. Now how 1? Okay, if we have any number or any base with the exponent of 0 is always 1. So 1 can be represented by any base with the power or with the exponent of 0. So in this case, we can also write 1 as an exponent with 0 and then repeating this as same. Now if you remember from part 1, whenever we had a division thing, we always subtracted the exponents. So in this case, 0 minus 3 is 3. So there you go. So 5 to the power of negative 3 can be also written as this way, which is 1 upon 5 to the power of 3, which is same as this. Cool, and with that, let's solve some couple examples when it comes to multiplying negative expressions. Let me clean out some space. Cool, and let me get my pen back. Okay, I will just write down this again here. And any base with an exponent of 0 is always 1. So using the same property, when we are multiplying same base with exponents, we always add the exponent. We'll use the same concept here, which is 7 plus minus 4, which is 5. 7 minus 4, which is 5 to the power of 3. So again, remember, base needs to be same, and we'll just use the same property for multiplying exponent to just add the exponents. So let's look at another example, which is 7 to the power 12 plus minus 6, so which is nothing but 7 to the power 12 minus 6 is nothing but 7 to the power of 6. Cool. So it's kind of similar, it's almost similar to multiplying two positive exponents with the same base. We just add the exponents. So if I want to generalize this, if I have a base a to the power of n times same base to the power of negative n, we will just add the base. Let me write that again, which is nothing but a minus m. So if we come across an exponent with negative power, instead of adding, it's just subtracting. Cool, that's how you multiply exponents with a negative sign. Okay, let's look at some more examples of converting exponents to an exponential form. So here we have three examples: 1 divided by 64, 1 divided by 25, and 1 divided by 9. In order to convert this to an exponential form, all we have to when I say exponential form, we have to write this fraction in terms of base to the power of some exponent, either positive or negative. Cool. So we know we can say 64 is nothing but same as 2 to the power of 6, right? So if you multiply 2 times 2 times 2 times 2, 6, you get 4, 4, 4. 16 times 4, 64. So 64 can be represented as 2 to the power of 6. And from the previous explanation, we know that whenever there is anything to the exponent of 0, it's always 1. So we can write this 1 as 2 to the power of 0 and then 2 to the power of 6 again. And why am I choosing 2? Remember, if we are multiplying or dividing terms with exponents, the base always needs to be the same. That's why I'm choosing 2 here. Let's say if this was 3 to the power of 6, I would have chosen 3 to the power of 0. Okay, so if you remember, we have from the part 1 of our series, when we're dividing exponents, for example, a to the power m and a to the power n, we always subtract the exponents. So in this case, this would be nothing but 2 to the power of 0 minus 6, which is 2 to the power of negative 6. Cool, let's look at another example. So we can write 25 as 5 to the power of 2 or 5 squared. This is also called as squared. And 1 we know we can represent as 5 to the power of 0, and 5 to the power of 2, which 5 squared. And again, why am I choosing 5? Because I want to have the same base. So this is nothing but 5 to the power of 0 minus 2, which is again 5 to the power of minus 2. Cool, let's look at last example. So 9 we can represent as 3 square, and 1 can be written as 3 to the power of 0, 3 square, and this is nothing but 3 to the power of 0 minus 2, which is 3 to the power of negative 2. Awesome. If you don't want to write this over and over again, the simpler way would be if we have anything to the power 1 over a to the power of m, we can just write this as a to the power of minus m. So this is the generalized form of a fraction converting to an exponential form. Awesome. So with that knowledge, let's look at some more examples, and let's look at the other way when we have a fraction. When we have an exponential form, how to convert to a fraction. So here we have 4 to the power of negative 3. We can also say this is 1 times 4 to the power of negative 3, because 1 times any number is that number. And if you know from our previous explanation, any number to the exponent of 0 with an exponent of 0 is 1, and also here if we have any base with an exponent or with the power of 0, it's always 1. We can write the same thing here, which is 4 to the power of 0 times 4 to the power of 3, and this is same as a to the power of m, a to the power of n. Let me write n again, a to the power of n. And our property says whenever we are multiplying exponents, we just add them. So this is a to the power of m plus n. Cool. So this is kind of similar to what we saw before, but since we have to convert this into fraction, this would be nothing but 1 over 4 divided by 3. So how? Because 1, let's trace it back. So 1 we can write it as 4 to the power of 0 and 4 to the power of 3. And if you remember from dividing exponents, we can just subtract the exponent. So this is same as 4 to the power of 3. Cool. Now how to convert this into fraction? This is nothing but 1 over 9 to the power of 5. And this is nothing but 1 over 2 to the power of 8. So if we have any base with a negative exponent, all we do is 1 divided by the base or exponent, but with the positive sign. So this is the generalized form of converting any exponential term with a negative exponent to a fraction. So again, going by an example, if it's 2 to the power of negative 5, it's 1, which is same as this, divided by a, in this case is 2 to the power of positive exponent, which is 5. Amazing. So this is how we do conversion of exponents, negative exponents to fraction. And this concludes our part 3 of exponent series. I hope you like this video, and I hope that you learned something about exponents, and I would again recommend you to watch all the 3 videos if you have any questions about dealing with negative exponents, or multiplying or dividing in exponents, or dealing with exponents that are separated by parentheses. I hope you enjoyed this video, and if you do, please subscribe to my channel, Easy Math, and please leave your comments below. Thank you.